Hey guys, so we did this part of the notes in part 1. And so now we're just going to take a look at a second example here. And the second example has a lot of the same steps, but it's a little bit different. And one of the key ways that it's a little bit different is in this second example, we can't isolate the radical because each side has a radical. It only works if there's one in the problem. And some of you are looking at it like, I don't see a radical. I don't see what I'm used to seeing in terms of a radical. Well, in this problem, radical shows up in a little bit different way. It shows up as a fraction for an exponent. So because there's a fraction for the exponent, that's what we're thinking for radical. Okay, so let's give me a little more room to write here. So in this problem, we are going to deal with that fraction exponent the same way as we did in the problem up above, but we're just going to attack it a little bit differently because we don't have an index, we have a fraction. So in our step 2, which is raise both sides to the same power, that part hasn't changed from what we did in the problem before. The only difference is how we find out what that power is. And because it's a fraction, we're going to use the reciprocal. So since this is 1/3, got a little questionable, sorry about that. Since it's a fraction, we use a reciprocal. So since it's 1/3, each side of this problem is going to be raised up to the third. Okay? The only tricky thing here is on the right-hand side, it's nothing. It's just good old 7x plus 5. The 3's cancel, everybody's happy. Or sorry, the 3 cancels the 1/3, everyone's happy. On the other side, the 2 is raised to the third, but it actually has to get raised because it doesn't cancel out the way the 1/3 does. The 1/3 is only around the stuff in the orange box. It's only around, okay? And so as I'm looking at that, I see some good stuff canceling, right? The 3 with the 1/3, the 3 with the 1/3. But the 3 also needs to hit the 2, and that's what makes this one a little bit more challenging, is we've got kind of some pieces here that we haven't seen before. Now, once we deal with that, then we solve the new equation, and that has not changed. Our goal is to get an equation that doesn't have a radical or doesn't have any fractions in it, and then we're just going to have at it and solve like normal. We're going to distribute. After we distribute, we're going to get all our x's on the same side. And then we're going to move that constant term over and get a final answer of x equals 13. Okay, so just a little bit of a difference when we're dealing with a fraction, but it shouldn't be so overwhelming as to like scare you away from these problems. But just know that when you see that fraction, it adds just enough of a wrinkle to kind of keep you on your toes. So be watching for fractions. Remember, you're going to use the reciprocal Well, just to clarify, because I think that might be a good option, when we say if we see a 1/3, the reciprocal would be to raise to the third. If we see a 1/4, the reciprocal would be 4. If we see a 1/2, we would raise to the second. And just because it's possible that you might have a crazy problem someday, if you saw something like 2/3, well, then you would raise to the 3/2, right? Because it's reciprocal. But I won't give you any like this. Delta Math won't give you any like this. So just be more mindful of the ones where the fraction is on top. So let me know if you have questions. I hope you have a great day.